You're gonna like this because I have like a method to finding the nth term for some of these sequences. Now this sequence doesn't look terribly difficult. I wanted to start with a simple one. It says 5, 10, 15, 20. I want you guys to try to come up with a rule by yourself right now with these numbers. Go ahead. Now I don't know about you guys, this works out for me. This is how it works for me. When I see a sequence like this, I think right away, oh, plus 5, plus 5, plus 5. Because I see like, oh, you just have to add 5 each time. But you don't naturally think first the number term and like what can you do with that number term to get that. Now I heard what some of you guys said, and I was really impressed. I was really excited that some of you guys found the correct one. But there are some other ones that aren't conventional, but they still work. What did you guys come up with? Who wants to share out? Yeah, what did you get?
5i.
You got 5i?
Yeah.
So you're saying a sub I equals 5i?
Yeah.
Okay, cool. Now we normally would use n for the nth term. You just gave me the ith term, but it doesn't really ask. We normally like to use i's for summation notation, but this works. Anybody else got a different rule? 5i minus 0. Yes, that would work. Okay. First period gave me this one. One student gave me this one. I thought it was kind of cool. Since we used I first, I'll use I again. They said 4i minus I. No, not minus I, plus I. Okay, they said 4i plus I. Does that work?
No.
It doesn't? Try it. It does work. But it shouldn't amaze you that much. Some of you guys are like, whoa, it works. But guys, what is 4i plus I? That's 5i, so it's the same thing. It's just like different. You guys are like, oh, okay. All right, now this is called an arithmetic sequence, and the reason why it's called an arithmetic sequence is because it has a common difference. A common difference is something that you can add to each number to get the next number. Okay, that's what the common difference is. How can you find common differences? You can find common differences most of the time just by looking at it, but if you can't tell, you would take two numbers. They have to be in order, so we're going to take 10 and then subtract 5, the second number minus the first number, and then you get 5. Well, then if you pick another two numbers like 20 and 15, and you subtract those, oh, I get 5 again. So this one has a common difference. If it has a common difference, then you know it's an arithmetic sequence. And it has to work for every single number that you know. Okay, and if you have a common difference, you can use the formula. There's a formula. Yes, for arithmetic sequence, the formula is a sub n equals the first number in the sequence, a sub 1, plus n minus 1 d. Yeah, d. D stands for your common difference. Yeah, d is your common difference. Let's say, maybe I should put an arrow. Common difference. I'm going to do shorthand right there. That is the D. So what's our common difference for the sequence? 5. Okay, so we would go a sub n equals a sub 1. Wait, what is the first term? 5 plus n minus 1 times 5. And then you go to simplify this bad boy, and you get 5 plus, and you distribute that 5, and you get 5n minus 5, and that simplifies to 5n. Kind of cool, huh? And you guys were able to come up with that answer without the formula. So you can see some of the sequences that you guys were working on last night, those are arithmetic sequences. Some of them you could use this formula. Okay. Another way you could have written this rule is something like this. You could have written a sub n equals a sub n minus 1 plus 5. What this says is that in order to find this, you take the previous number and then add 5 to it. Okay, now this is a recursive type rule, so it's a recursive sequence.
This is kind of recursive?
Now here I'm just showing you guys how to write it recursively, but this would be the answer that you'd want to write down. A sub n equals 5n. So let's try one more. Now this one, it's not so obvious. I'm telling you right now, this one is an arithmetic sequence. What are we going to be adding each time to get this? It looks all tricky because it goes non-fraction, a whole number, an integer, to a fraction, and then a fraction, and then back to an integer. It's like, what the heck? What's going on right here? Ah, there you go. Some of you guys are seeing it. Very nice. Now, what if you couldn't see it? What if you couldn't see it? What would you do to find your common difference? You would subtract. You would take the 10 over 3 and subtract 3 from it. Well, I make the 3 to be a fraction, then have common denominators to be 3 on the bottom and 9 on the top on the numerator. And now we get 1/3, right? And let's try these two numbers. So we have 11 over 3, and we're going to subtract 10 over 3, and we get 1 over 3. Oh, look, has a common difference. And so our common difference is 1/3. Our rule is going to look like this. A sub n equals, what is that? What's our first term?
3.
Yeah, 3 plus n minus 1 times 1/3. Now, just because it says n minus 1 right here, I mean, that shouldn't surprise you. And let me show you why. To get a 4, we're starting with 3. How many common differences do I need to add to get to 4? Three of them, right? You go plus 1/3, plus 1/3, plus 1/3, right? 3? Okay, now look what a sub n gives you. It takes the number of the term, which is the n, and it subtracts 1. What's the number of the term? Well, for this one, the number of the term is, see, that'd be a sub, whoops, it'd be a sub 4. Dang it, I can't write right now. A sub 4. So, if I plug in 4 right here, that would be what? 3. You see how it takes it just takes 1 away from it and says, oh, I have to add 3 1/3 to it. Does that make sense? Here, let me write it another way. If I am looking for a sub 4 here, I know that I'm supposed to get 4, but I'm just testing it, I guess. I have 3 plus, it says n minus 1. What's my n right now?
4.
It's 4, so it's 4 minus 1 times 1/3. Now, 4 minus 1 is 3, and we already decided we needed to add 3 1/3 to get the 4th term, right? There you have it. And so that's going to equal 4. I actually do all the work and stuff. Okay, so here's the formula to find the rule, and I plugged in everything I know to find it, but I haven't simplified it yet. So I got to take this, and I got to go 3 plus 1/3 n minus 1/3. You guys see how I got that? By distributing this. And then I combine like terms. So what's the like terms? 3 and 1/3, and so that's going to give me what? What is 3 minus 1/3?
4/3.
No, minus 2 and 2/3 plus 1/3 times n. That equals a sub n. That's my rule.
Wait, we're not allowed to have improper fractions?
No, you can have improper fractions. I think mixed numbers are easier to add and subtract, though. Actually, no. Take that back. Mixed numbers are normally easier to add with. Subtracting sometimes is a little more difficult. If you want to, you can make them improper fractions and subtract it that way. And you can leave the answer with an improper fraction too. I don't care.
Well, like on our first